So welcome everyone to the October meeting of the Philadelphia Dynamo user group. Thanks for everyone for being here. We're glad to have you all from all over the country and all over the world. I know we've had lots of different registrants from all over the place, so thanks for joining us. Philadelphia Dynamo user group, we're very proud this month to be presenting Rhino-Inside Revit with Joseph Freund from Microsol, along with some help from Scott Davidson from McNeil. So just a little bit about Philadelphia Dynamo user group. So we are a collaborative community for computational designers in the Philadelphia area. We're happy to have everyone from other places join us today. We're trying to really focus on the Philadelphia area to help really grow our community here. So everyone that's in Philly, we're especially proud to have you guys here tonight. We try to focus on Dynamo, but we also expand to a lot of other related technologies, which is why we're looking at Rhino-Inside Revit tonight, and especially some of the interaction with Grasshopper that tool enables. But we do lots of other technologies and try to really make a good home for people doing computational design. Next month, we'll be doing an event. We don't have the date set yet, but in November, we'll be doing PDUG office hours. The idea with this is that we haven't been able to meet in person for a little while. So we want to give people an opportunity to just ask questions to each other. We'll try to get a couple of experts online and maybe break out into some separate individual rooms to kind of deal with different topics. We're going to try to maybe pre-register some questions, get some ideas going ahead of time and really develop some good conversations in a couple of different places and really just help everyone learn a little bit more from the community. One thing to note for this upcoming meeting, we will not be posting this to Eventbrite. So if you want to join this meeting, you're going to need to subscribe to our mailing list. If you go to our website, pdug.co, there's a subscribe button on there. You can join our mailing list, and we'll be sending out the information for that from there. So lastly, I just want to thank our partners, Microsol and Revit Gods. They've been helping us to bring PDUG to you and get the word out for everything. So we're really happy to have our partners to help us out with everything. I'd like to welcome Joseph Freund from Microsol and Scott Davidson from McNeil and Associates, who'll be doing the presentation tonight. Scott will mostly be staying in the background and piping in if needed, but Joseph will be doing most of the presentation tonight. So thank you both for being with us, and I'll turn it over to you.
Thank you, Dan. I just want to again welcome everybody to this presentation. My name is Joseph Freund from Microsol Resources. It's an Autodesk and Rhino reseller. And I know that Scott and Hassan from McNeil are joining in the background. Hopefully this presentation won't require a fact check press release or anything afterwards, but yeah, we can get going right away because we've got a lot to cover here. So first thing, I'd just like to cover some of the different software that Microsol Resources sells and supports, from Autodesk to Rhinoceros and any CAD learning, online learning solutions, all available through us. So if you are in need of any of the software or looking to renew, feel free to reach out to us and we'll provide a quote. We also provide training classes from Revit Essentials to Revit Family Creation, as well as AutoCAD in case anybody is still using AutoCAD. And yeah, we also teach Rhino Essentials as well. So yeah, if anybody on your team needs some training, some new hires or anything like that, feel free to send them our way and we'll be happy to provide the classes. So I'll just get started here. As you can see in my background here, I'm in the virtual classroom. So this is sort of how we conduct our training classes. But so for today's presentation, I'm going to be starting off with an introduction to Rhino inside Revit, showing you how to get it set up, what you need beforehand, do a little introduction to the interface of Grasshopper and Rhino for those that are unfamiliar. I know that this is a Dynamo user group, so maybe you're at least familiar with visual programming or hypergraphs, but this will just present that in a slightly different view. And then we'll go through some workflows, primarily going from Rhino to Revit. And then if we have time, we can cover the workflow of going from Revit to Rhino, and that's in case, you know, we've seen many customers that have, for example, V-Ray for Rhino, and they want to bring everything in so that they can render it in Rhino. And I've got a workflow example where you can bring in families all the way down to the individual components and assign them to the right sublayer and material. And then we'll wrap it up with a Q&A. And like we said, Scott and Hassan will be handling any questions through the chat, but we'll scoop up all the rest at the end. Okay, so what is Rhino inside Revit? Really, what is Rhino inside? It is this technology that McNeil has created to basically embed the entire program of Rhino into another, very similar to how any plugin is created. But you know, as we all know, Rhino is a very powerful geometric tool that is only made stronger through Grasshopper. So to be able to embed such a program into another is it's really mind-blowing when I heard about this. So it's very exciting technology, and it has many benefits beyond just the access to the technology. You have access to all of the various plugins that are available just for Grasshopper. There are many that have been created for Dynamo and Grasshopper, but there are many that are still just exclusive to Grasshopper. So you would have access to those, such as Grasshopper, Human UI, things like that. And some of our workflow examples, some of the workflow examples will cover those. This also gives users agency within a firm. If you have somebody in your firm that is a Grasshopper or Rhino expert, then this technology allows them to enter into design teams more fluidly. Whereas before, if it was necessary to export a model from Rhino and import it back into Revit, that is no longer necessary because you're using this technology, and both data structures are working side by side. So that gives anybody in your firm that knows Rhino and Grasshopper a little bit more of an edge. There's also hiring flexibility. You don't need to only hire somebody that has a certain amount of Revit experience. If you can bring in team members that are very knowledgeable in Rhino or Grasshopper, you don't need to discard them from the pile, as I'd say. Additionally, this brings all of the full features of Rhino 7 and Grasshopper into the Revit space. And all of the pains of importing and exporting and having certain geometry not show up the way that you intended are almost entirely a thing of the past. Just because, like I said, the data structures are just right up next to each other, and so you can send data and geometry directly to the other. And that includes, parameters, attributes, geometry, all that good stuff. Now there's also Rhino Compute, which is, it's more related to, let's see, Rhino Compute is really a stateless REST API that provides the capabilities of managing Rhino geometry, but from the cloud. So this provides a lot of potential down the line, as there seems to be a major shift toward cloud computing and kind of decentralizing the storage and collaboration. Okay, Now onto the setup and installation requirements. So Rhino-Inside Revit works with Revit 2017 all the way to 2021, and I'm sure 2022 and 2023 when they come out. Now, if you already have a license of Rhino 6, then you automatically have access to the Rhino 7 work in progress, which has recently been upgraded to beta. And with that, you get a 45-day trial of Rhino 7. As long as you still have that Rhino 6 license at the end of that 45-day trial, you can just go ahead and download a new work in progress or beta now, and you should be good to go. And then there are regular updates to the Rhino-Inside Revit installation, which is the actual plugin for Revit. And just like any other add-in within Revit, you open it right from the add-ins tab, and it's as simple as that. Now I'm gonna switch over here to the website. So this is rhino3d.com/inside/Revit/beta. And this has all of the information that you could ever want for Rhino Inside Revit. I think the documentation has been tremendous here in anybody that has a little bit of curiosity in this area. So right here, you've got the download for the Rhino Inside Revit. And then here is the download to the Rhino 7 beta. Now there are many guides to get started. As you can see, all of the navigation off to the left here. It is quite robust, and more is added daily or weekly. A lot of sample files in here so that you can kind of take a look under the hood and see how everything is really put together. Or how they're achieving this sort of functionality. There's also a nice reference guide and community links here. So I think the original website I had here, inside/beta/Revit/beta, is a tremendous resource. So I just wanted to flash that real quick. And before I forget, I think I had some links here. I'll copy some links into the chat box a little bit later. Okay, so a little bit of an introduction to the interface in Grasshopper. So this is your main canvas space that you'll be developing your scripts. And as you can see, there's the Revit tab up top with all of those beautiful icons there. And I really love the development there because it's so useful to be able to recognize what the function of a node is based on the icon that is there. No need to hover over it and get a better sense or rely on the name of it. I think that the icon is a very very useful addition there. So generally with the functionality here, what we're doing is one of three things. We're either accessing or editing information from an existing Revit model, and that includes elements, parameters, families. And in this way, we can have better understanding of our Revit model, and we can manage a project a little bit better. There's also this opportunity to create new Revit elements from Rhino Inside Revit. And this includes geometry, adding parameters in, and basically using Grasshopper and Rhino as a design tool for Revit. And again, this is all within the Revit space. Rhino Inside Revit is using the memory space of Revit in order to function, so it is able to create these entities directly. And lastly, you're also able to create Rhino geometry from the Revit model elements. So you can extract data for analysis, you can bring in an element over into Rhino, redesign it, and then push it back into Revit. There's a lot of different workflows that are possible here. So I'll just be covering a little sliver of them here, but but it's really exciting. Okay, those are all the names of all of the tabs up above. Should have put that animation a little bit before, but all it's good. Okay, and here is a little introduction to some of those components, some of those nodes that can create the new geometry within Revit. So it includes adaptive components. So as long as you've created an adaptive component family in Revit, then you can reference that. And as long as you provide the same number of points as our adaptive points in that adaptive component, then you should be good to go. As long as you know, points aren't too close or anything like that. And we can also create beams, columns, and walls by specifying a curve. And this is similar to the functionality that you can see in Dynamo as well. And then you can also work with family instances and direct shapes. Now, from what I understand, family instances is more of the what users are calling for, but direct shapes, I think, have their place in the design process. Maybe it's just in quickly pushing a conceptual model into the Revit space, just so that it can be viewed in context of the rest of the Revit model. It can be used in many different ways. And then you can place family instances by locating a point and indicating a template family. And one of the workflow examples will go into that. And just like all the rest, you can also create floors and roofs from polylines. They'll need to be closed planar curves, obviously here, but functionality is there. And in addition, there are many different analysis tools within Rhino inside Revit. And like I said, there's more functionality almost every day. And maybe at the end of the presentation, Scott can cover some of the newer features that have just been released or are about to be released. Okay, so let's go here. Let me just Alt-Tab over to my other machine. So I have this familiar Revit model open here. And so when you open up Revit to, well, I've got all of these zoom controls getting in my way, sorry. So you go to the Add-ins tab, and if you have Rhino inside Revit and Rhino 7 beta installed, you'll be able to go here, click on this, and what will happen is this Rhinoceros tab will show up. And these are the different options you have here. So you can open up Rhino directly from Revit here. So I think that's just hiding behind my Grasshopper window. There we go. So I have that in the upper corner. And you also have the option to import geometry directly from a 3DM, a Rhino model. You can preview, you can add Python code, you can go directly to Grasshopper, and then there are various visibility settings here. You can also control the solver within Grasshopper. And the solver is essentially whether the script is automatically computed with any change. And then right here, you can specify any category that you want to bake any of the objects to. And lastly, one of the workflow examples should cover this, but there's this Grasshopper Player, very similar to the Dynamo player, but it allows you to load a Grasshopper script, run that, and then no need to actually open Grasshopper and have it run and close. There are certain workflows that this may be smoother for. For example, in Revit model health checks, if you work it into the daily routine to have your users open a certain script that exports data from the model, then you can have a full report at the end of the day of the state of the model. So that's it's a good way to include those sort of scripts easily into the workflow, especially for any users that are not familiar with Grasshopper. So without any more delay, let's open up Grasshopper and get going with some of these workflow examples. So let's go ahead and open a document here. I've got my first one ready to go here, and this is going to be using the Revit model, specifically using two edges from the Revit model to then create a surface and then push that back into Revit. So let me give you just a quick rundown of what we're seeing within Revit here. So as I showed before in the PowerPoint, we've got all of these wonderful panels across the Revit tab here. So this is all Rhino-Inside Revit across here. But in addition, there are parameters listed here. So you've got a few right down here. And these are very helpful for using these Grasshopper scripts with the Grasshopper Player. And then you have these different Revit primitives. So in the case of this example, what I did was take the edge here, placed it in, and then that's what these two are. And what I'm doing is just referencing a couple of edges that exist in the Revit model. So I'll just reassign these here just so that it's clear. Oops, I'm going a little too far ahead here. Okay, so I'll just orient myself here. And what I'll do here is right click, and then I'm going to set one Revit edge. And I'm just going to pick an edge on the top of this roof right here. Okay. I'll lock that solver. And I'll back up again. Sorry, I'm showing you the ending before the middle. Okay, go back here. And then I'm going to select another Revit edge. And I'm going to choose this one along this parapet. So now I have my two edges selected here. I'll just go ahead and get rid of that there. And now these edges are going to flow into my script. Now this boundary here now shows where I'm transferring from Rhino-Inside Revit components to strictly Grasshopper components. So everything I'm doing in here is just Grasshopper. I'm bringing in these two edges, I'm lofting into a surface, and then at the end over here, I'm passing that on back to Rhino-Inside Revit. So let me just show what this looks like in Revit here. Unlock that solver. So now you can see the preview is shown. Let's go ahead here. Okay, so the preview is shown. Sorry about that. Okay. The same as it would show in Rhino, but it's displaying this within the Revit model space. So that's very helpful just to be able to visualize what you're working with in the Grasshopper canvas. So now this surface is brought across this border into the direct shape creation here. So I'm just going to go and re-enable this. I should have had it disabled from the beginning, but such is life. And I'm going to disable preview here. So I'm just seeing that surface. So now I just have this nice surface that is based off of two edges from Revit, surface created in Grasshopper, and then pushed back into Revit here. Now, as you can see, it's categorized as a roof, It's not a generic model or anything like that. Okay, gotta wait for this to go back up. There we go. So that's what this is creating. This is pushing it back into Revit. And I'm specifying the category here, and I'm specifying the name right here. Now, if I look at,
it's not there?
I want to do it.
Can somebody mute their microphone, please? All right, thank you. Okay, now this is an example of changing a parameter for this roof that I have just created. So this is looking for the parameter key mark, and I'm just going to change that parameter value to mark text 2. I'm just going to go ahead and enable that. Now, if I go back to Revit here, just cancel that. And if I select this again, what's going on here? Might need to refresh. All right, well, maybe I'll just back up here and show what's going on in here. So this is just some Grasshopper, a bit of Grasshopper to add some perforations to this roof here. And what I'm going to do with this component, which is the stream filter, and I'm going to use this kind of like the design options in Revit. And right now it's just bringing in the surface, but I can toggle this so that it brings in the perforated surface that I've created here, which if I go up to, if I just view my Rhino model space here, I can see exactly what I've created. You can see those perforations there. And if I want to bring that into Revit here, just toggle that to true, and then it should update in Revit accordingly. Okay. So that's one way to bring some Revit information into Grasshopper, have some manipulation to it, and then bring it back into Revit. All right, I'll just move on from this. I think I'll have another example where I'm resetting the parameter on an element. Let me just see. All right, I'll move on. Okay, so I'm going to close out of this one. And I'm going to open up my family components. Now this one should be a little more fun. So I'm going to zoom out here and set the scene right here. So I'm working with some columns here. So I have this geometry that I've created in Rhino beforehand. I've internalized this into Grasshopper. What I'm going to do is bake this so that it is in the Rhino model space. Now what I'm going to do is select that geometry, right-click my geometry node in Grasshopper, and then set that one geometry. So now, as you can see, this has changed from orange to gray, and it is now referencing this BREP. So now I'm going to change that over so that everything downstream is referencing this BREP in model space. I'll just go ahead and shut that off. So now if I make any modifications within model space, it should update here. Now, I'll show you exactly how this column is created within Revit, and then I'll make some of those modifications. So what I'm doing here is feeding in the column. It's relocating and then repackaging right here. And then once we get to the Rhino inside components, what I can do here is create a new family within Revit with this new component family. And if I maximize this, I can show you exactly where to get this. So family, new component family. So what I'm feeding into this is one, a file path to the column that I want to use as a template. I'm going to set override to true. I'm going to name the column rotunda, and then I'm going to put it in the category columns. So I'm going to go ahead and activate that node. And then let me snap this back off to the side so that we can see what is happening in the Revit space. Now, let me change this to what it should have been, which was that rectangular column. So here's that column that I first created. Well, I first had it in Grasshopper, but right now I have it in the Rhino model space. Through this script, I am creating a new family and placing it. And then right down here is where I place many different instances of that family. And this is based on a curve with the number of points, and that it was created right back here. So what I have is a circle where I have divided that circle up into a certain number of points. And then fed those points into my script so that that is the location that I place each of these new family instances. Okay, so now if I go back to this item that I'm referencing in the Rhino model space, and if let's just select an edge right here, then I'll use the gumball to modify where this edge is. That's going to feed in, and as you can see, it eventually updated it in the Revit model space. And I can just keep doing that. Just as a general recommendation, I would say if you can avoid doing this sort of live linking, especially if you have more than just a small collection of families that you're placing. But for the exercise of this demonstration, I think it's completely fine. So as you can see, all of these automatically updated based on what I changed in the Rhino model space. So that's a neat little feature there. And then I'm going to go down here. I'm going to just swap that rectangular column, or what used to be rectangular column, with a different column. This is a column that I've created through a Grasshopper definition that essentially creates a hexagon, twists it around, and tapers it slightly. So I'm going to switch this back to 0. And now it's going to update with the new geometry that I'm feeding into this flow. So that's going to come up here. It's going to create that new family component, and then it's going to replace those same families that it did before, but with the new geometry that I've created here. So that's a nice way, a nice alternative to design options. I've found that design options can be a little cumbersome at times, and I definitely find this kind of way of generative design a little more, a little easier to work with. Now, in addition to toggling the rectangular array or the circular array, I will just arrange these in a rectangular array instead. So instead of this circle determining where my columns are, I'm going to switch it to this rectangle, which has a grid here. So instead of these circles here, I'm going to have a grid of columns. And I could change that just with a flip of a switch here. And as you can see, automatically updated here. Now I think I've got a little something here, but it's just a preview from Grasshopper. So that's one way to create new families with Rhino inside Revit, where the geometry either starts in Rhino model space, or you can create a parametric family within Grasshopper. All right, now I have some additional things down here where this is an example of finding all of the structural columns within this model. And again, this is all Rhino inside Revit nodes right here. So this is going to query all types of structural columns that are in the model. And then this filter masks gives me a nice list of all of the different structural columns that are in the model. So I can go ahead and select one here. Then this component gives me all of those elements just in a list here. And then I can find the location of each of those. And based on that location, I can then place or swap out any new family. So what I could do first is activate this, which is the same kind of component as the previous, where I actually placed each one of the instances. So now if I go back to the Revit model here, and I look inside this glazing, yep, okay, so I have now swapped these columns in here for the new column. So it's a good way that you can create new, you can swap out any existing families in there, and because you can just create and place new families, I see it as no different qualitatively to working in Revit. It's just, you know, choose whatever works best for you. What are you best at? And you know, Grasshopper just has a lot of great tools available. Okay, and I would also need to run this command to delete any of those previous structural columns. So that's a nice little feature there. All right, go ahead and save that and close. And let's see, what's our third one here? Okay, adaptive components. This one should be fun. So this one I'm using Kangaroo as Kangaroo and a new feature called Quad Mesh. So what I did initially for this example, let me go wide full screen here. I took an image that I took of a hummingbird, and through the image sampler in Grasshopper, I was able to then create a closed polyline from that. So let me find where, let me get rid of this here. And I guess I need to enable the solver. There we go. So there's my outline of the hummingbird extracted from the image sampler. So now if I feed that into my quad remesh, it's going to create, well, let me pick one where it's actually going to show the boundaries. It's going to create this mesh here. And I just think this has done a tremendous job of subdividing this into quads. So each of these segments in here is a quad. So it has 4 points that determine its shape. And that's important when applying any of these adaptive components. You can have those that have 3 points, 4 points, 5 points, however many points, as long as it syncs up with whatever the adaptive component has. So I'm going to use this structure, this mesh structure, to create, well, in this case, I'm going to create a pavilion, a hummingbird pavilion, or jungle gym, whatever you like. It's a space frame, something. So I'll go ahead and turn off visibility for these. And then I'm going to set up the kangaroo definition here. So what I'm doing right here is just setting up different physical forces that can be applied to each of those edges that were on the that were in that mesh that was shown. And I feed all of that into the kangaroo definition here, and then that's going to feed in my resulting points at the end. So let me just cut to the chase here and reset this. Okay, so it's run one iteration. That just resets the kangaroo simulation. But I might want to show this in Revit just for, I forgot to get rid of those columns there. Yeah, let me just select all instances and unpin. That's another thing to remember. Anything that is created through Rhino inside Revit comes in as pins. So if you want to get rid of it, you'll need to unpin it. I think it's good that it comes in pinned though, because that just makes sure that it stays put. Okay, so I want to see this simulation of Grasshopper, but in the Revit window here. So this button will reset the simulation. So it only goes through one iteration. But if I click the play button on this trigger, it's going to run this simulation once every 100 milliseconds. So if I run that, ooh, look at that. I feel like I could just run this. I've already done this where this is a fun button to click. So it's nice to see it come to an equilibrium. Okay, looks good. My space frame is set here. If I want that to be a little shorter, maybe I come back here. Here, I'll set that to play again. And then maybe I'll change some of the parameters a little bit so it's not as tall, but oh no, maybe I do want it as tall. So there we go. And I'll stop the simulation. So now I have a space frame with many edges connected here. And now, and they're all quads because I created that through the quad remesh. And now I can use those quads, the 4 points that consist of each quad, and assign an adaptive component to that. Now I've already pre-created an adaptive component, but it's very easy to create. I mean, you just, there are many templates out there, and basically just create a rail and a section cut, and it'll create the form. So in this case, my adaptive component is just a frame with a certain parameter that controls the thickness. So if I come over to this component here, enable that, it's going to let all of these points, which are grouped into groups of 4, to flow through, and it should then add the specified adaptive component, or apply that adaptive component to each one of those quads. All right, there we go. I'm just going to lock the solver here and zoom in just to see what we have here. Okay, looking good, looking good. But the thickness, they're all the same thickness. So I've created this. Now what I can do is modify a parameter. I've created that parameter that's part of the adaptive component called adaptive thickness, and I'm going to set that to a number that is based on the orientation of the panel. Basically, how far vertical is it oriented, or is it, if it's more vertical, then it'll be a very light thickness. If it's fully horizontal, it'll be almost completely closed. So my Grasshopper definition defines that number, and then if I activate this component, it should modify the parameters for those placed adaptive components and should update the thickness accordingly. So as you can see, let me just lock that solver. Bring this over. So now, as you can see, there's varying thickness all throughout here. And now we have our space frame of adaptive components. So that's a fun little example. I'm not pushing some hummingbird agenda on you, but just trying to use that as an example to show what could be possible, and that it doesn't always need to be orthogonal to work out. So this is the main component that accomplished the placement of each of these adaptive components. And then after I created it, I modified the parameter right here. So that's basically how that one works. Let me just save that and close. Now for this one, I want to show how it works from the Grasshopper Player. So I'll just go here. This dialog will open up. I'm going to open up this human UI Grasshopper definition. So when I open this, a new window pops up, and I have two different parameters that I can change: drawn by and checked by. And this will be what appears on any title blocks in the within the project. So I can go ahead and type in my my initials here, drawn by, checked by. I will just go ahead and click the button here on each of these to commit them and go ahead and close. Now if I go to my sheets, I'll just open up one of these sheets. There's my hummingbird and drawn by, checked by. Now you didn't check to see whether that was, it could have been like that before. So let's just, for good measure, open this up. Yeah, let's just change it back to none. There we go. And one more time. There we go. And this can be applied to any parameters on any element. You can make these changes. So this can be very helpful for these larger projects that just there's all kinds of data going every which way, and it can be difficult to manage all of it. And this just allows you to very quickly and easily determine what needs to be changed, and do it from Grasshopper if you have a specialist that's knowledgeable in that. Okay, let's see. Not sure why it's bringing me back to Grasshopper here. Try and open Grasshopper directly from Rhino. Nope, it's right down here. There we go. Okay. Now I think we might have time for one final example here. Now this is connected to the Revit model health. I've been doing a lot of Revit model health checks lately, and I decided to make use of the tools in Rhino inside Revit to extract data from the Revit model. And this is just going to be one example of this. So I'll go step by step here. So first, I'm going to use Rhino inside Revit to query all views within the project. So that's going to be everything listed here. It's going to take in all of these views. Now, in this section, I'm extracting a few items. I'm extracting the name of the view, the family and the discipline, and feeding in the values of each of those into my merge component here. But in addition to some of those parameters, I need to do a little more work to get more information. To determine whether a view is on a sheet or not, it is necessary to check and see, okay, what is the name of what is the value of the parameter sheet name? So if it doesn't have a name here, then I can be pretty confident that it does not have, that view is not on a sheet. And the more views that stack up in a model, the more that, it just bogs down the performance of the model. So the more views that you can create that are going to eventually be on sheets, the better. And to have an excessive number of 3D views and scope boxes and things like that can make it difficult to work with some of these models. So that's another metric that I'm extracting, whether the view is on a sheet. I'm also taking the view depth of each of these views. For a lot of elevations, it's not necessary for the view depth to be so large. You only need to see really what's right in front in many instances, especially for the interior elevations. But if the view depth is too far, then Revit will have to bend over backwards to process all of those elements that it's really not even going to display much, or you don't even need it to display too much. So I'm feeding all of these metrics into my merge component here. And then doing a little cleaning. I'm finding because in the end, I'm going to create a CSV from this information. I wanted to remove any commas that were in any of those values so that it writes properly. And then this is just a little component here to actually write this to a CSV. There are many different ways to accomplish this in Grasshopper. This is just one that I've chosen. I've got a file path here, a little Python script, pretty simple. Really just checks to see if there's already if the path exists, and if so, go ahead and write all of this information to it. So I've successfully run this script without error, so it should be available in my folder here. So let me just open that up real quick. All right, that's not the right one. I'll be an example, data metrics. Okay, so I created this views.csv. And so this is what I'm working with after the fact. Now, okay, having it in CSV, that's fine. It's information, but it may be a little difficult to parse. At this point, you can use many different tools to visualize this information. I've really enjoyed using Power BI to visualize some of these. So I've actually imported that CSV into Power BI. That way I can have an interactive sort of engagement with this sort of data. So I can click on each of these view types to see if there's a particular view that that is not on any sheets and may need to be. I think ceiling plans are often the perpetrators, but yeah, just another way to extract information and view it in a more I hate the word, but digestible way. Okay, so that's that process there, and this can be done with all kinds of different Revit model information. You can query views, you can query all different types. Materials, view types, families, types, elements, walls, categories, levels. So you can extract all kinds of information very quickly and easily through Rhino inside Revit. Okay, so I'm just about wrapping up with some of these workflows. Do you think we have enough time to do a Revit to Rhino workflow?
It's right about 7 o'clock now, so I think we probably could do a few minutes more, and then we should probably move on to questions.
Okay, sounds good. I'll just do this one real quick. So this is going to be a Revit to Rhino workflow. So this is using one of the example files from McNeil's website. And yeah, if I double click this, you can see Scott Davidson wrote this one. And basically what this is doing is specifying the category that I want to query. And then I am filtering all of these elements and collecting all of the elements that that satisfy that filter. So everything that's a roof. And then I'm extracting the category name here, just so that it's perfectly clear. And then I'm feeding those elements into this component, which will effectively create Rhino geometry. So if I snap this over, bring my Rhino window over, I can now see my roofs, even the one that I created a little bit ago. So there are my roofs. So that's created in Grasshopper and is only showing it as a preview in the Rhino model space. And if I want to bake that, I can just go ahead and press this button. It'll bring all of that geometry in. And it will put it on a layer the same as the category from Revit. Now that's one way to bring these in. Let me just check with the walls here. That might be another neat one to see. Only a few walls. I think, yeah, maybe I'll just go straight down to the windows here. Now, because window families typically contain multiple materials, I figured that this was a good opportunity to show this sort of functionality. So I'm bringing in the category windows, collecting all of the elements, and then feeding this into certain workflow here where I'm using Rhino inside Revit to extract all of the elements that would show in the 3D view here. And then I'm feeding that through to this Grasshopper component, which effectively organizes the information so that it will create a sublayer within Rhino. So this is going to create a layer windows with sublayer frame and mullion. And then in this case, I have Elefront, which can take in the attributes and bake items into the Rhino model space. But you can also use that same Python component here. So I think this is a very neat aspect to the development of Rhino inside Revit. This is kind of what I spoke about when I said looking under the hood. You can learn more just by entering into this process, especially at this time, because it might not be that all of this documentation and all of these files are always available. So it's a good chance to get into this right now. But okay, so I have two options. I can use Elephant or I can use this. I'll go ahead and use the Python script. So I'll just toggle this to true, and it's going to bring in all my windows into here. Now, if I zoom in and I select one of these, go to properties and confirm that, okay, that's on the layer glass. Got the frame there. So it's split everything up into the appropriate layer. And as you can see, I've got my sublayers listed here. So if I had a Rhino file already created that has all of these layers pre-populated with materials and names that link back to the same as the categories in the Revit model, then I could be well on my way to starting a rendering with Rhino, either through the Rhino renderer or V-Ray for Rhino, whatever you may have. So that's the main Revit to Rhino workflow here. So I'll just go ahead and close out of this. And I know that I said that I was going to bring over, I was going to share some of these links through the chat, but here they are. Here's that first link that I mentioned. Great resources on Rhino3D.com. If you're just getting into Grasshopper, there's some great videos on Vimeo. There's also the discussion boards at McNeil, discourse.mcneil.com. All of the wonderful plugins that you can find for Grasshopper are on foodforrhino.com. And those are Grasshopper plugins in addition to Rhino plugins. There's also Grasshopper 3D on YouTube, Rhino tutorials on Vimeo. Just added in microsolresources.com, just in case you have any questions specific to purchasing or support of the software. And then this one I've found very useful, Jeremy Tamek's blog, The Building Coder. I really think that I've learned more about Revit and the Revit API through Rhino Inside and also through Jeremy. And it's really been a great resource. So I'm going to copy this into the chat box so that you can copy it onto your own machine. And yeah, I think that just about wraps it up here. I hope that was very useful for everyone. And I hope not too much was in conflict with the official McNeil sort of press release.
Only after the first 10 minutes. No. No,
So,
great.
All right, so let me stop sharing here.
Yeah, Scott, is there anything that you want to add as we're getting some of the questions coming in?
Oh, questions would be great. I mean,
okay.
We can cover a lot of things, but questions would be awesome.
Sure. So there's a couple of different questions. I'll kind of maybe address some of the easier ones first. So one quick one, someone asked about the video. All of our PDUG sessions are recorded and will be posted to our PDUG YouTube channel. So just search for Philadelphia Dynamo User Group on YouTube, and you'll be able to find that. One question, which has already been answered in the chat, but we'll answer it here also. Does Revit geometry come into Rhino as a mesh, polysurface, or what form does it come into Rhino as?
From Rhino or Revit into Rhino, it comes in as a NURBS BREP solid. So it's nice geometry coming from Revit into Rhino. And
is there any limitations?
Yeah. Yes, go ahead.
Go ahead, sorry.
Oh, and I was just going to say that that direction's easy. Yeah, because Rhino, has a kind of a bigger geometry kernel. The other direction gets a little bit more difficult in that most solids in Rhino will get across to Revit. Curves will get across, points will get across. Revit has some limitations in terms of its geometry kernel, like the length of edges and things like that. And so some of those will, like in a direct shape, it'll come across as a mesh, or you might have to do some cleanup of the geometry in Rhino in order to get it across to Revit properly. So, but the majority of stuff gets across just as it is.
Kind of a related question, are there limitations in the terms of complexity of the initial Rhino shape? And is there anything that you have struggled to translate, particularly interested in recreating facade Rhino models into Revit?
Yeah, most has to do with edge length, like making sure, Revit's minimum edge length is 1 millimeter. So anything below 1 millimeter it'll get rejected. And so you get into situations where like you get into situations where for a fabrication facade, you're going to want edges that are very, very small sometimes. And so what we usually look at is in Revit, if you're looking for LOD 300, for instance, how can you simplify the model a little bit in certain cases in order to get LOD 300 in Revit, but have the fabrication data maybe kind of continue through Rhino. It's just one way to think about how to get things back and forth. And on the discussion forum, if you have geometry that's not getting across, we'd love to see it. We'd like to see if there's any way we can fix it or help it or go through that process. If that's helpful.
What are some of the most interesting or creative uses of Rhino inside Revit that you have seen?
I have to think of all of them.
You've probably seen many more than I have, but
I was going to say, Joseph, what do you got?
No, I don't know. I've been exploring sundial design with mine, similar to the Hummingbird Pavilion, but no, I've
seen the front of facades driven by music, musical structure. We've seen that. Just generally, complex facades have really been the big part. You can think about it as the overall driving shape of the building is very, very complex, but the adaptive component or the final panels are simpler. Oh, here's a good one: the new Raider Stadium. The new, or what they're called, the Las Vegas Raiders now. So Allegiant Stadium, that's one you can look at. That's an adaptive component using Rhino-Inside Revit. So if anybody wants to look that up, just search for Allegiant Stadium, the Las Vegas Raiders. That would be the most fun. So
great. Can you assign materials to Rhino objects before it is baked into Revit, or assign native Revit family materials?
Yes. Yeah. So and that's actually we have, you can do existing materials in Revit onto objects, subcategories, objects within families, and then in our next release you'll have the ability to actually make materials on the fly. So yeah.
Someone asked, how is Rhino inside Revit priced? And it looks like it's free as long as you have a license of Rhino 7.
Yes.
Right.
Had to think about the answer on that one for a second. Yes, it's free as long as you own Rhino.
Is there work on making more explicit baked to Revit portions of Rhino inside? Right now, the real-time binding of Revit Elements makes it tough for multi-step scripts. To break the history, we have to close or reopen the Revit or to sync.
Yes. So yeah, that's element binding, and element binding is coming in one of the more hopefully sooner than later. We're working on it. Element binding is difficult to get right, and so we're working on that.
And I saved one of the earliest questions for last. You can feel free to keep posting questions, anybody that has them. But specifically for this group, since we are a Dynamo focused group, why would you use Grasshopper or Dynamo? What would you feel like the strengths from one or the other be, and why would you use one over the other?
$1 million question.
Don't everybody jump at once.
Yeah, no, I mean, it's, for me, it's personal preference. I think that just the flow within Grasshopper works much better for me, and maybe that's in part muscle memory of being familiar with it. But like I was saying about the icons, I think that there's a certain level of that the interface has developed in Grasshopper to be to present you with just the right amount of information, but not so much that that it's taking up all of your real estate on your screen. So yeah, it can be down to you know, making fewer clicks to just get the same sort of script down onto the canvas. But I also love all of the wealth of plugins and the community that comes with it too. I think
so this question, like adding to what Joseph said, this question came out at the start of the presentation, and I was thinking there's a lot to be said about the user interface of an application and everything else, like how usable it is, how many clicks you have to do stuff, and all that kind of stuff. On top of it, Grasshopper, those are the stuff that's more about like the application's user interface. On top of it, Grasshopper has access to Rhino's geometry engine, which means that almost anything you want to do with geometry, especially parametric geometry, is possible. Think of intersections, creating complex surfaces, shapes, and all that kind of stuff. New Rhino 7 has subdivision geometry, which is really cool if you're, especially in working architecture. You don't have to make a complex shapes out of independent pieces of NURBS anymore. Like you can build the whole thing as one geometry, and then it sort of like translates into NURBS and then comes into Revit as well. So amazing geometry engine, and then you have access to 40 plus whatever file formats that Rhino has access to. You can create your own custom importers and exporters. You can read the information from your Revit models, export it, or vice versa, however you want to in your Grasshopper definitions. But the sort of like one of the most important things about any utility is that is the ecosystem around it. Like in terms of when you talk about the programming language, the libraries that are available for that language are really important, because those are the real ones that give you the actual functionality, real world functionality that you're looking for. One of the nicest thing about Grasshopper is that it's just massive ecosystem of tools and components and everything that's been created for it. So you have access to all of those inside the same Revit environment that you're running. So any Grasshopper add-on you install in your Grasshopper, when you load inside Rhino.Inside Revit, you'll have access to those.
How about advantages of using Rhino Inside versus Rhino or Mantis Shrimp?
So the Rhino and Mantis Shrimp use, you know, a method of translating through some alternative format, and what Rhino Inside allows you to do is you actually are inside Revit with the same data structure, and so what's happening, we're seeing this happen a lot, is that it's not just one way of translating. It's you rig your data and your geometry together, and that can actually change, and it can change by phase of project. It can change by the part of the building that you're working on and where it is in the piece. And so it's a lot more granular control about, you know, how things, how information and geometry are flowing back and forth between, I'd say the two products, but they're not two products, it's one. So between the two interfaces. And so that's an area that we're seeing quite a bit of experimentation. A lot of people, you know, solving problems that are specific and custom to their design problem that they're trying to solve.
As Scott said, one of the main architectural differences between Rhino-Inside Revit and the rest of the products is that most of the other applications that adopt sort of like an interoperability between these two applications, they usually go, they usually use the sockets and in-memory connections between the two applications, two running instances of an application. The case with Rhino-Inside is that Rhino-Inside loads Rhino as an add-on to Revit. So all these three applications, well, two applications and Rhino-Inside Revit as the binding piece, they're all in the same memory space. That means that whatever you used to in sort of like writing C# for Revit or writing scripts, Python scripts in your Dynamo and all that kind of stuff, all of that will work inside the Rhino-Inside Revit, and you have access to Rhino API and Rhino-Inside API to do the geometry conversions and stuff for you. Usually, when you separate these two applications and connect them through a socket connection, you have to provide APIs that provides that sort of like transport of information between the two applications. So you can't really directly talk to the API. In the case of Rhino-Inside Revit, you can literally directly talk to the API just the way Dynamo talks to the API or any other Revit add-on talks to it. So it's very, very extensible for the future.
And one last question about what is the cost for Rhino 7? And I think, Scott, you'd said it's not exactly done yet, but should be similar to Rhino 6.
And so, and then I put Microsol's pricing page up there and the information about getting Rhino and from them, along with your Revit, if that's what you'd like to do. So.
Okay, so I don't think we have any more questions. I apologize if I missed any questions for anybody. Yeah, I don't think there's anything else in here. So thank you everybody for joining us tonight. Like we said, we'll be posting the video of this session to our YouTube channel. We'll be posting all the links in the description of the YouTube channel, and we'll be trying to get those up on the PDUG website, pdug.co. If you have any questions, feel free to reach out on any of this stuff. And like I said, if you have not already given us your AIA number and would like credits for this session, just make sure you send them to us via email. And if you have to self-report, please do that within 10 days. Thanks again to Joseph, to Scott, and to Ehsan for helping us out tonight and presenting this really great tool. Really amazing stuff. So I think we're going to see a lot of people really excited to be using these new capabilities directly within Revit. Thanks again to Microsol for sponsoring our AIA credits, and to Revit Gods, our partner in presenting these talks. And we will hopefully see many of you again for some upcoming Philadelphia Dynamo user group meetings. So thanks everyone, and have a good night.